In this video, we will discuss about electric potential. Before we directly go to the definition, let us do a simple example, which we have already done. Let us see. This is your a charge, positive charge, whose location is fixed, and another one charge Q0 is brought from infinity to this location A, and Q0 charge is brought from infinity to this location A. Since because of repulsive force, I have to do some amount of work. So I have done some amount of work from infinity to A. If I have brought this charge from infinity to this A in such a way that at each every location, this point or this charge is moving with a zero acceleration, then this whole amount of work is stored in the form of potential energy or electric potential energy. So that is electric potential energy is equal to 1 upon or is equal to work done, that is equal to 1 upon 4 pi epsilon naught Q, product of charges Q naught, and distance between the charge, this charge, and where we want to keep it here. So distance from this charge to this charge, A location. I can take location is R. So it becomes R. So this is your potential energy, which we have already discussed in the previous videos. Now further, here the potential energy depends upon this charge. The charge which is brought from infinity to this respective position. This formula, potential energy, doesn't tell us about what is the effect of this charge, which is fixed one, at this location, because the potential energy is a product of charges. It depends upon the product of both. If any one of these quantity is less, the whole product is less. So what we do is, can we remove this Q naught from this formula? Can we remove the Q naught from this formula? So if I take this Q naught to this left hand side, so it becomes W, that is from where to where? Infinity to A. Infinity to A. A means particular location. Divided by Q naught, it becomes 1 upon 4 pi epsilon naught. Q naught is gone, divided, and it is R. So this is this much. Now this term, that is work done per unit charge, is independent of this test charge which is brought from infinity to this location. So this term which is independent of this one, that is known as a electric potential. So how will you define this electric potential? The electric potential can be defined as it is the amount of work done to bring a charge from infinity to this respective position per unit test charge. So it is defined as I add a unit here itself. So this is your electric potential. So electric potential is generally represented by capital V. To understand more, let us do this example. See here, I am having a charge whose location is fixed, and I want to find out the electric potential at point A, which is at a distance of RA. So from here, the electric potential at point A will be equal to 1 upon 4 pi by using this formula. 1 upon 4 pi epsilon naught, source charge. Source charge, where is the source charge? This is source charge, which is Q, and distance where I want to calculate the electric potential. I want to find out the electric potential at this point. So here it becomes, this distance is RA. Now if you want to find the electric potential at this location, that is B, Then what will be the electric potential? VB is equal to 1 upon 4 pi epsilon naught source charge, that is Q, divided by distance where I want to calculate. I want to calculate here. So I want to find out this distance. So this distance is RB. It is RB. So this is your electric potential at different location. From here you can see that if the charge is more nearby, then the electric potential is more. Because the distance is less, it is in denominator, the electric potential will be more. If you go more near to the source charge, electric potential will be more. Further, it also depends upon the magnitude of this charge. If the sign is positive, then it will be more. If it is sign is negative, then it is the whole cases will be reversed. See here, if charge is negative, then it will be negative 1. Now, here the distance is less. Distance is less, but this quantity will be more. More negative. More negative means as a whole less. So, if the charge is positive, then more nearby the charge, more will be the potential. If this charge is negative 1, if you bring it is more nearer, then the electric potential will be less. If you don't understand this one, see here. To understand this more, let us do this example. Suppose this is a source charge Q and potential at this point is 10 volt. And at this location, the potential is 20 volt. If this is positive charge. So since here this charge is more nearby as compared to this one charge, so I take this as B and this as A. So the B is having more potential as compared to A. Now if this charge is negative Q, then same distance at same point, this A, this is B, this will become minus 10 volt and it becomes minus 20 volt. Minus 20 volt. Now see here, which one is greater now? Minus 10 is greater because it is less negative magnitude. So A is having more electric potential as compared to B. So this is how the electric potential varies for the positive charge and for negative charge. Now let us do further. Now let us do electric potential difference. So difference we have done. So now let us discuss electric potential difference. So difference, here name is also suggesting it is a difference between the two electric potentials. Let us see here, suppose this is a Q charge and whose position is fixed, positively charged, and another one charge, suppose I want to find the electric potential at point A and electric potential at point B. Now from C here, the potential at point B I take it as a VB, potential at point A I take it as a VA, and the distance of VB is RB and distance of this location A, I take this distance as an RA. Now from this diagram, the electric potential difference name is suggesting us it is nothing but it is a difference of electric potentials. So if I want to calculate the electric potential of B, what should be the electric potential of this B with respect to this one? So I write it like this VBA. And it becomes VB difference of electric potentials, that is VB minus VA. Now further if you solve and we use this formula, So what we get? So what will be the electric potential at point B? We know the electric potential at point A and at point B is what? 1 upon 4 pi epsilon naught, magnitude of charge, that is Q, and distance. Distance is R, A. Similarly, at this point 1 upon 4 pi epsilon naught, source charge and distance of B, that is V, R, B. From this one, what is VB and what is VA? From this relationship, VB will be equal to 1 upon 4 pi epsilon naught charge divided by distance of point B. That is further is equal to amount of work done to bring the charge from infinity to the location B per unit test charge. That is Q naught. Similarly, VB we have calculated. Now VA 1 upon 4 pi epsilon naught Q divided by RA. Source charge is same. The location is RA. That is equal to amount of work done to bring a charge from infinity to A location per unit test charge. Now if you put this observations in this equation, so what do we get? It is amount of work done. I make it more farther. So VBA is equal to amount of work done from infinity to B per unit test charge minus amount of work done to infinity to A per unit test charge. If you solve it, so what do you get? Amount of work done to bring charge, I am writing only VB minus amount of work done A, and that is Q naught. So what we get? Electric potential difference is nothing but it is just to bring a charge from A to B per unit test charge. So further we can define here, it is defined as this amount of work done to bring a charge from one respective position A to B. Means WB minus WA is nothing but it is amount of work done to bring a charge from A to B. So this amount of work done from A to B per unit test charge is known as the electric potential difference. So this amount of work done from A to B per unit test charge. So this is your electric potential difference. This is your all about. Thank you.